Statistics Part 1 video. Well, what is statistics? Statistics is the art of studying problems and answering questions by collecting and analyzing data. So basically, we're going to be looking at data. So first thing we need to know is there's different types of data. There's categoric variables, which are which describe a particular quality, or characteristics. It can be divided into categories. This collection is called a categoric data. So let's look at some examples of categoric data. The type of car that you own would be categoric data. Your gender, female or male, would be considered categoric data. Your grade level of a student, such as are you in the 10th grade, 11th grade, 12th grade, junior, senior, sophomore, freshman. That is categoric data. In addition, the letter grade that you make in a class would be considered categoric A, B, C, or D. The types or the subjects you take in school, those are also categoric: science, math, English, French. Here are some illustrations of graphs that we will be using to describe categoric data. There are bar graphs, which each bar represents one of your categories, or a pie graph or circle graph, where each piece of the pie represents the right proportion of the data that's represented. The next type of variable we have is quantitative variables, and these are also called numerical variables. So quantitative and numerical mean the exact same thing, so we can use those terms interchangeably. Now, numerical data is divided into two types. There is quantitative discrete variables, and that's where you have an exact value, a single value, or a continuous discrete variable. So let's look at some examples of quantitative discrete variables. So these are examples where you have an exact number value. Okay, the number of people in a household would be considered a quantitative discrete variable. The score you made on a 30-point test, where you can only get 1, 2, 3, 4, 5, up to 30 points. A number of goals that you score in a game. The next type of quantitative data is called quantitative continuous data. And this is where it has a continuous range of values that the data can find. A good hint that you're going to probably use this if you see measuring. Anything that can be measured, you can always do data in between. So let's look at some examples of quantitative continuous variables. Or remember, we could also call this numerical continuous variables. One example would be the weight of the students in the Integrated Math 3 class. Another example of a quantitative continuous variable is the height of college professors. And then another one of a quantitative continuous variable is if you were measuring the length that a rocket takes. Here are some examples of data that graphs that we'll be doing that involves quantitative data, numerical data. On the left, we have the box plots. These are some side-by-side box plots. And then on the right, toward the bottom, we have what's called a histogram. And then finally, here we have a stem plot. And this one exactly is called a back-to-back stem plot. Make sure, notice how it has a key here at the bottom. It's very important that back-to-back or stem plots, you include a key. So let's look at a few examples here. You might want to pause and see if you can figure these out. So classify each of these variables, these data. Okay, the number of pages in magazines, well, that's quantitative discrete. The manufacturer of a motorcycle, well, there are different companies, so that's categoric. Position taken by a netballer, well, that's categoric. The time it takes to swim 100 meters, well, that is quantitative continuous, because we have any time in between to the millisecond. The temperature in Brazil, well, that's quantitative continuous. Temperature is constantly changing. A person's preferred football team, well, that's categoric. The width of a person's hand, that is quantitative continuous. And the area of a block of land, quantitative continuous. Next thing we're going to look at is once we have data and we start graphing it, we're always going to describe our distribution. So with every graph, we're going to write a few sentences describing our distribution. Well, one way we can look at that is we can look and see if the distribution is symmetric or skewed. So here in the green graph, we have a symmetric graph. Now notice normally the most common thing occurs at the tip of the symmetric graph. And then so here is a symmetrical graph. The middle one is a negatively skewed graph. And notice that the tail goes into the negative direction. And here's a positively skewed distribution. So notice the tail goes to the positive direction. So what you're going to do is you're going to look at your graphs and you're going to classify them as symmetric, negatively skewed, or positively skewed, if possible. Sometimes it won't match any of these three. The next thing we're going to do when we describe a set of data is we're going to talk about a certain number, and it's called the measure of center. Now we have three numbers to choose from. There is the mean, the median, and the mode. We'll talk a little bit more about which ones to choose when later on, but let's just figure out how to calculate each of these. The first one is the mean. Well, the mean is equal to the sum of all the data values divided by the number of data values. So it's our average, arithmetic average. Here's some new notation. This little funny e is called the summation notation, and it just means the summation of x just means the sum of all the data values. And also x with a little bar over it, called x bar. That is our notation for mean. The second measure of center is called the median, and this is the number that's in the middle of a data set. Now, in order to figure out the number in the middle of the data set, what you'll really have to do is first you're going to have to rewrite all your data into increasing order. So you cannot find the median until your data is in increasing order. Once that happens, you just simply find whichever value that is exactly in the middle of your data set. This is really easy if you have an odd number of data points. If you have an odd number of data points, the median is the number in the center of your data. If you have an even number of data points, you have two numbers in the middle. So you take the two numbers in the middle and then you find that average, so divide by 2. So the two numbers in the middle divide by 2. And that's the two ways of finding your median as your measure of center. The last measure of center is called the mode. The mode is just simply whichever data value that occurs the most often. So the most frequent data value. So let's look at an example. Here we have the number of small airplanes flying into a remote airstrip over a 15-day period. Find the mean. So again, remember the mean is equal to the summation of x over n. Well, summation x means I just take all my data points and I add them together. So just write them out, put in a plus in between every data point. Notice I do include the 0, although it doesn't have any value. I want to add all of the values. And then I divide by, now I count how many data points I have. Looks like I have 15. And now I simplify down. So mean is equal to 66 divided by 15. Then we're going to punch that into our calculator, and we're going to get 4.4 aeroplanes is our mean number of airplanes flying over the 15-day period. Okay, B, let's find the median as our measure of center. So again, first thing I got to do is got to rewrite this data set so I have it in increasing order. So I'm going to write my smallest number first, and then I'm going to increase until I get to my largest value. Now I'm going to find the number in the middle. So since I have 15 data sets, I know my number in the middle, it's an odd number of data. So it's going to be a single value. It's going to actually be one of my data points. I could take the 15 divided by 2, 15 plus 1 divided by 2, and that means I need to get to my 8th point. So that's one way you can do it. Or you can just simply mark through as you go to your data point. So again, I could take my n plus 1 divided by 2, and then I'd count from my left up that many points. So 15 plus 1 is 16, 16 divided by 2 is 8, and notice that 4 is in the 8th spot. So my median is 4 aeroplanes. The last step you can do is you can find the mode. The mode is just the number that occurs most often. So notice here I have 3 4s. So 4 aeroplanes would be my mode. Okay, let's look at another example, but this is just separated a little bit differently. It's in a frequency table. So we have the number of students and their scores from 1 to 10. So to figure out our mean, we got to figure out how many 1s we have, how many 6s we have, how many 5s, etc. So we're going to do our product. We're going to take the score value times how many students got that score, and that'll give us our product value. Now I'm going to add all these products together, and I get a total of 157. So a mean score, remember our formula for mean score, is our total of the scores divided by our number of scores. So here our total would be 157 and the number of students is 20. Divide that out and our mean score is 7.85. Now let's find our median, the number in the middle. So again, you have different ways that you can do this. I can physically figure out all the tick marks. I know a lot of people like to do the physically out. Or I could take my n plus 1 and divide by 2. So I got 20 plus 1 is 21 divided by 2. Uh-oh, I got two numbers in the middle here. So this means I got 20 is an even number, so I want to find my two 10s in the middle. In this case, they're both a value of 8. So 8 plus 8 divided by 2 is still 8. So our median is 8. Median is a score of 8. Mode. What's the score that occurred most often? It was the 8. So our median score of fitness for our students is a score of 8. Okay, here's another example, another way that might show how to do this. We're going to find the mean of 6 scores is 78.5. What is the score, or is the sum of the scores? We're going to use our formula here. We know mean is 78.5. Sum is what we're going to find, and we know we have an n is equal to 6. So we're going to solve this equation for sum by multiplying each side by 6, and we get our sum is 471. So the sum of the scores is 471. Our last example, find x in if 10, 7, 3, 6 plus n x have a mean of 8. So mean is equal to sum of our data points divided by n. So our mean is 8. Our sum of our data point is 10 plus 7 plus 3 plus 6 plus x divided by how many data points we have? Well, we have 5. So let's simplify this down by adding those numbers together. We get 26 plus x over 5 is equal to our mean of 8. Multiply each side by 5. Subtract 26 from each side. And we get x must be 14.